back. Now, let's do some more complicated questions. Let's see if we can find the resultant of a whole bunch of vectors. Okay, so we're going to dive right in because we like this section. All right. First question, 2 boys pull a crate to the right, giving you direction. 1 boy pulls with a force of 20 and his friend pulls with a force of 50. Then I say determine the resultant. Now we need to get used to the language, okay? I've said determine the resultant. I haven't specified for you how I want you to determine the resultant. Remember, we can do it by a calculation or we can do it by construction. So we're going to do it both ways because I want you to see that it doesn't matter. If the question had said calculate, I'm telling you how I want it. If the question had said draw by construction, draw a scale diagram, I'm also telling you how I want it. But this said just determine. So let's look at it with a diagram. They both pull to the right. So that's going to be my positive direction. I'm going to call this force F1, and I'm going to call this one F2. The only reason being the 20 was given first, the 50 was given second. If I did it by construction, I would draw an accurate line of 20 newtons, which is going in that direction. Then I draw another accurate line of 50 newtons going in that direction, and I draw it one after the other, head to tail. My resultant is always from the beginning of the first one to the end of the last one. You have to get that stuck in your brain because you're going to use it lots over the next few years, okay? From the beginning of the first one to the end of the last one. So here's the beginning of my first one. Oopsie, it goes all the way to there, and we would then measure it, and it gives me 70. But I need to write down what the resultant is. So I say my resultant force is 70 newtons right. That's by construction. If I do it by calculation, I now need to go my resultant force is my first force plus my second force. My first force was 20, my second force was 50, so that's 70 newtons, and it's positive, not that I could get a negative, it all went to the right. I still need to say to the right. I'm finding a vector must have size and direction. I need to know where it's going. Good. A girl pushes a heavy box with the force of 50 newtons to the right. Another girl is also pushing on the box, but she's pushing with a force of 70 newtons to the left. And again, determine the resultant. Now, instinctively, you can all tell me that if one girl pushes to the right and the other one pushes with a bigger force to the left, the box is going to go to the left. You can do it instinctively. It's just part of your makeup. It's not something you actually think about twice. But we need to put it in scientific terms, which is what we're doing. They said again, determine. So I don't mind how we do it. So we're going to do it both ways. We're going to do it by construction, and we're going to do it by calculation. So, starting with this one, we have a 50 Newton force to the right. There's my first one. Then I have a 70 Newton to the left. Now I start at the head of the first one, and I go 70 Newtons to the left. Remember what I said to you? The resultant is from the start of the first one to the end of the last one. So my resultant is there. We would then take out our ruler and we would measure it because this is accurate. And what we should get is that that's 20 newtons. So I would go, my resultant is 20 newtons left. And instinctively we knew it would be left. We just now have the size. Let's do it by calculation. What I like to do is I like to go what is a logical choice for direction, but it actually doesn't matter. If you want to always be doing the same thing, choose the original direction. Whatever direction you get given first, make that your positive direction, because then you've got a system. So I'm going to make to the right positive, which means to the left is negative. This is my first force. This is my second force. So when I do the addition, I go my resultant is my first plus my second. My first is 50. My second now becomes minus 70. That minus is important because it's direction. It's telling me that it's in the opposite direction to the 50. That, I need to know that. If I do this and we go 50 minus 70, we're going to end up with minus 20. We now have to be careful. That minus 20 is telling me that it's going in the left direction. But when I give my final answer, I never use a negative value. If I have to do a calculation with this, then I use it. But this negative value gives me direction. So I'm going to describe it. I'm going to go, that means that my resultant is 20 newtons left. I always leave my answer as a positive answer with the direction in words. I know the negative means a direction. I know it implies a direction. But I want it in words. Very, very, very important. I could have chosen to the right is negative. The difference will be that I will end up with a positive answer at the end, which then means it's going left. It doesn't make a difference, okay? There we go. We have a runner. He's training on a flat, straight road. She runs 10 meters north, 7 meters south, and then 125 meters north. We want the resultant. So what has she done? She went 100 meters north. So I'm making this direction my north, so that's 100 meters. She then went 75 meters south. And then she went 125, I should have drawn this differently, 125 meters north. Now I need to know the resultant, and this was a very bad diagram. My resultant goes from here to there. Nope, I lied to you. My resultant goes from the beginning of the first one to the end of the last one, and this is why you draw it better than I did, because you don't go into your hand, into your writing. This, when it's lots like this, it's much easier to do this by calculation. So what I'm going to do is I'm going to say north is positive. Okay. I can't use F because F means force. I've got a distance here. Okay. So I'm going to go, her resultant is going to be her first distance, which was 100, minus her second distance, which was 75, plus the 125, okay? So let's just get this, do it on our calculators. So we've got 100 minus 75 plus 125, and we get 150. And we get a positive 150. So she ended up 150 meters north of where she started. And I'm not sure that was expected. I'm sure some of you went, that was a bit further. I'm not talking about how far she ran. It's just where she ended up compared to where she started. Okay, that's her resultant. So she could have got to the same place by just running 150 meters north, instead of going 125, 125. But she was in training, so that's what we do. Okay? So, there we go. And lots that we did. So remember, direction, direction, direction. You can find resultants by construction or by calculation, but only for vectors. For scalars, you simply just add them all together. Wow, lots to think about, lots of new concepts. But it's okay, the more you practice, the better you get. So we're going to stop there for today, and I will see you next time.